Today's topic, IMS Connect Reimagined, leveraging SQL to access IMS data in today's digital ecosystem. Okay, I'll be speaking about the modernizing IMS Connect to support newer technologies and architectures. Architectures such as cloud computing, RESTful APIs, and microservices. Then we can dive into setting up the environments optimized for Java and Python programming techniques, ensuring smooth interactions with the IMS databases. Then I'll speak about events and traces that can be captured to diagnose the problems, empowering IMS Connect environments with the robust tools for efficient troubleshooting and performance tuning. So before we begin, yeah, before we begin about myself, um, my name is Santosh Dorge. I am lead product developer in the PMC software and located in Pune, India. It's 10 p.m. here at the moment. I'm not sure if I shall be saying good morning, good afternoon, and maybe good evening. People are joining from the global locations here in the virtual meeting today. I work on PMC AMI data for IMS products. So that's about me. Um, Today's topics, we're gonna speak about. Let me get the pointer. We're gonna speak about the IMS Connect overview. Those who are new to IMS Connect, I'm gonna speak a little bit about IMS Connect overview and the address space. Then I'm gonna speak about access to the IMS transactions from the web technologies or TCP/IP. Then the message formats for the input request messages, and then message flow and the problem diagnosis in the transaction access area. Then uh, we'll be touching to the database access to the IMS, data access to the IMS using SQLs, using distributed data management protocol. Then we we're gonna discuss about the input request message routing for the ODBM messages. And I'll be speaking about the events and traces, common challenges throughout the development, testing, and the production phases with the IMS Connect and the OTMA, ODBM interfaces. Then lastly, we can discuss about evolving the IMS Connect environments to keep innovating in the IMS Connect area. We can speak about data scraping for the analytics and deriving the insights for the artificial intelligence. So that's the list of topics coming up in the current presentation here. Okay. So IMS Connect is the address space, separate address space in the IMS. It's a component of the IBM IMS family of the products. IMS Connect serves as a gateway that allows applications to interact with the IMS databases and transactions using standard communication protocols like TCP/IP and HTTP. So this enables seamless integration of IMS-based applications with the modern technologies and provides access to the IMS transactions and the data from wide range of platform and the devices. In the picture, you can see here the applications or the interfaces like data power, universal DB resource adapter, driver, IMS Connect API clients, or the SOAP gateway. An IMS TM resource adapter can communicate with the IMS Connect address space here over the TCP/IP. And then we have the BMC AMI Energizer for IMS Connect tightly coupled into the IMS Connect that provides the that facility to capture traces and empowers the IMS Connect environment. And whole address space communicates with the IMS OTMA or the XCA to get the information or execute the IMS transactions without modifying the mainframe side of the system or the environment. Okay, key benefits with the BMC AMI Energizer for IMS Connect um, are like better availability through the dynamic changes and does not need an outage, even if there are changes needed to the environment, like but changing to the routing or um, adding a new data store to the IMS Connect environment. It can be done dynamically and improved product productivity by eliminating the need for coding the similar message user exits. You can uh, use the virtual exits. You don't need to maintain the IMS Connect user exits and code the assembler exits. That thing can be eliminated with the standard features that are provided with the virtual exit. And you can use the traces and the journal data sets for diagnosing the problems. You can use the graphical user interface to see the analytics out of events occurring in the IMS Connect address space. Okay, so that's about uh, IMS Connect address space. And if we are speaking about the transaction access uh, over the TCP/IP, IMS Connect facilitates the transaction access through the OTMA. One need not to modify the existing resources on the mainframe side. They can just start building the applications on the on the open system side and start communicating with the IMS Connect, use the existing transactions, and information can be used in the open system side applications, the responses. And it allows the application to interact with and retrieve the data from IMS databases. This capability is crucial for enabling the distributed applications running on various platforms to efficiently access the um, data stored on the IMS database without modifying the programs running for transaction access from different terminals. So that's the transaction access. Let me show you this here. Okay, it supports for the growth of evolving technologies, as I said, without modifying applications in the mainframe using open transaction management access. Then OTMA uses the cross coupling facility to send and receive the messages. And then you can have one IMS Connect to connect to the multiple IMS control regions in multiple escape groups. One IMS control region can connect to the multiple IMS connects. So it's like one-to-one, one-to-many, or many-to-one connections can happen between the IMS control region and IMS Connect address space. IMS Connect and IMS can be on different LPARs in the same sysplex. Okay, into the next slide. So this is the picture shows the sample configuration or the environment to enable the IMS transaction access. On the GUS side, one can have GUS Connect address space established in order to define or in order to create the APIs, REST APIs based Java and Python applications, or the cloud applications can access the APIs. Um, in turn, that will be sent to the IMS Connect, and IMS Connect will get information from OTMA. It can run the transaction in the MPR, access the data from the IMS database, and back to the GWS Connect API application. Alternatively, one can create the applications using IMS team resource adapter or the port level connections, socket connections connecting to the IMS Connect port, and on the same path to the transaction manager executing the transaction in the IMS and returning in a response to the client client created outside the mainframe system. So IMS Connect provides the exit routines or the mechanism to modify the behavior of the IMS Connect. You can evaluate the input message coming from the application to the IMS Connect, and uh, you can code the behavior how the IMS Connect will um, work on that particular input message and send it to the OTMA. At the same time, um, you can change the output behavior of the IMS Connect for the output message to the client. So input message is of the format like there would be the full word length and then IRM 28-bit fixed length IRM, and then LLGG data ending with the string 00004 x of 00004. It can use the something called extended IRM, um, and it is of format this. Or alternatively, it can use the pre-built OTMA headers like shown here. OTMA can understand the information only in terms of OTMA headers. So applications developed as Java APIs or as the TCP/IP port connection here, they send the information in the format shown here, and ultimately IMS Connect converts that information in the OTMA header, which can be processed by OTMA in order to execute the transaction in the transaction manager uh, and MPR. Okay, this is the configuration for the transaction access. You the one can define the proc for the IMS Connect, which is HWS00 HWS00 program being executed in the IMS Connect procedure, and there is parameter HWS that parameter points to the proclib member where one has to code the TCP/IP parameter, and the data store parameter um, that enables the TC transaction access to the IMS data store. So these are the parameters that are defined in the DAPS-PB member of the proclib. These values here shall match to the one in the DAPS-PB member of the proclib. Okay. Again, then data store is IMS data store ID, group is XF group, member is the value in the DFS PB member, Apple shall match to that of the Apple ID defined in the DFSPB, and then IMS Plex member equal to the name of the IMS Connect address space, and the team member is the name of the IMS Plex here. Okay, then you can define the multiple data store IDs here. These are the data store IDs that are defined as you know the applications can send information to these data store IDs here. All right. So this picture here shows the sample code for the transaction access using Java program. The Java program can be part of the application outside the mainframe. It can be anything. It can be programmed in the cloud. It can be program that provides the microservices, or um, it can be programmed in the cloud applications. So as I showed on the previous slides, the one way is to create the IRM in the format uh, of LLZZ data, and send it to the IMS Connect port. It can connect to the host and port number, and it will get connected. It will send the information to the IMS Connect socket, which will be continuously reading the information received on that socket, and will send it um, to the exits. And from there, it will go to the OTMA. Again, will follow the same path, wherein from OTMA it will be scheduled on in the message processing region and get the response back to the client. So IMS ships a Java library, uh, IMS udb.jar, um, and one can use this library to create the application, or one can use the resource adapter or the socket level connections, and have their own format of the IRM to be analyzed by the exits. So it's completely customizable, wherein the standard fixed format of the IRM can be followed by LLZZ data, which will be the specific or the customized formats, and IMS Connect will still handle it. Okay, next, this is another example of executing the API using the Python program, wherein in this program I have part-tran API being called, and the response is being displayed. So I created this API using GOS Connect um, Explorer or the REST APIs, and then I post it onto the GOS Connect address space, and from there, the connection has been established, like I was showing on the previous slides here. Let me go back to the slide. Yeah, right here. So my Python-based application accesses the API from GOS Connect, and in turn, it sends the information to the IMS Connect in term. The API converts GOS Connect converts the API information into the format required for the IMS Connect, and then it will execute the MP transaction into the MPR without modifying the transaction, and it can display only the selected information or expose the only required information that is defined in the API. So going back to the slide where Yeah, that's about this is sample API. I used existing tools to create the API and display it here, the information. Okay, this is the BMC snap from the BMC AMI log analyzer summary report. Summary equal to all, uh, LUOW detail equal to all, and this report, when executed using the SLDS and the IMS Connect BMC AMI Energizer for IMS Connect journal. So what I did, I executed one transaction um, from the TCP/IP interface, and then I got the SLDS of that time, and I got the journal of the same time, and executed the BMC AMI log analyzer report to see the flow, mm, how the messages, and how the transaction was executed. So it was like first few records, it was in the IMS Connect. So IMS Connect prepare read, it was continuously reading on the socket as soon as the message received on this particular port. um, it prepared the programs, IBM programs prepared it for the read, and then socket, the information was read from the socket. So these two events here, event 60 and 73, indicates the information was received from the client, and then user exit entry. I use this HWS sample one exit, and then user message exit. So message entered into the exit, message um, is going out from the exit, and what was the written code at that time, what was the reason code at that time, and then it says the message sent to IMS, and again uh, from which IMS Connect it was received, the TCP IP address of the IMS Connect address space, and the client port ID from where the message was received. And then it went into the IMS data store 01. As you guys know, its message is queued up, and what was the information on the message at the same time, message in queue, then program is scheduled, and then what is the recovery record. These are all log records up to here, and then again message is coming from IMS to IMS Connect. So what we sent to the IMS, what we are receiving from the IMS, again what exit received, what was sent from the exit, and then program ended, and then at the end, the IMS Connect ends the socket connection, closes the socket connection. So this is complete end-to-end flow, how the message arrived in the IMS system from the TCP/IP world. At each point, what was the changes that system had made to the particular message, and this kind of information helps in diagnosing the problem. Whether it is erroring in the exit, whether it is erroring in the IMS data store, or whether it is the response erroring out. So it it is helpful in the production environment as well as in the test environment when the applications are being tested. Okay, I'm moving to the next slide. So that was all about IMS Connect transaction access through the mm, IMS transaction access through the IMS Connect from the TCP/IP um, applications, and how to diagnose the problems, message flow, what is the format of the messages. Now over to the open data access to the IMS database. So BMC AMI Energizer for IMS Connect enables you to route the workload specific to to the specific ODBM address space by providing the virtual aliases and the result grouping. Um, and it enables tracing and journaling at certain points so that diagnosis or the problem determination becomes easy. Okay, let me jump on to the next slide here. Access to online IMS databases from anywhere in the enterprise. Then OpenStack application developers can use relational interfaces without changing IMS applications and database. Then it uses the DDM protocol or the DDM code points. And if I got to speak about ODBM, ODBM receives the database connection request from the IMS Connect as DDM commands, then translates the incoming databases request from the DDM protocol into the DLI calls expected by IMS. IMS does not understand the DDM protocols, so it has to be converted to the DLI protocols, and that's what ODBM does for the IMS. And then IMS data manager gets the information to the ODBM, and ODBM returns it to the IMS Connect and the client application. Okay, that's what this line says. Translates response to the client into the DDM protocols. And this is the picture sample environment, how the control blocks in the distributed relational database architecture looks like for the data access to the mm, outside applications without executing the transaction. Let's say data is stored in the IMS database, and application outside the mainframe needs access to the database, certain segments or certain fields in the database, and there is no transaction available in the current IMS transaction manager system. So there is no need to write the transaction, but the applications in the distributed environment like Java or Python programs can code the SQL queries to access the information stored in the IMS database. So again, it is type 4 JDBC type of connection that can be established between application and the IMS Connect port. We call it DRDA port. Then the universal DB drivers can be used, or universal JDBC drivers can be used in order to establish the connection here. And and, Energizer can help you to route these messages to uh, designated or well-equipped IMS system through the ODBM. It can route the incoming messages to the data store that is well equipped to or that has the resources defined to serve the request, or it can load balance as well between the multiple IMS data stores here. Excuse me. Okay. So here, when the message comes from the open system application, it is in the format of DDM commands, and then it goes as a DDM commands to the ODBM, and ODBM converts it to the DLI calls. Then these DLI calls are served by the database manager to access the information stored in the online database and return that information back to the client. Here is more about the information uh, of the message format. DDM commands, reply messages, and chain objects begin with the 6-byte uh, DSS header, uh, followed by the two bytes of LL, This is 6 byte and this is 2 bytes. This is again 2 bytes called code points. Code points is a list of functions that are requested through the DDM commands. So every function has like query data or reply data. Every function has different code points defined. Uh, this is standard DDM protocol code points that the application has to send to the IMS Connect, and then DBM can convert it to the DLI calls. Okay, jumping on to the next. Uh, this is the example of how to configure the data access in the Proclip member of the IMS Connect HWS configuration. The last 3 lines here indicates the data access. One has to define the DRDA port number, and then IMS Plex, and then ODBM connection, different parameters here, like timeout or how long the connection will be alive uh, when there are no messages. So those kind of parameters needs to be defined. The main here is ODA access, and then DRDA port equal to, and then which IMS Plex the ODBM belongs to. Um, then another thing required here is a new address space along with the IMS Connect address space. ODBM address space is a separate address space that needs to be created, and then that there is need for the SCI, OM, and RM address spaces, uh, which is CSL Plex, and then one needs to define the IMS catalog as well in order to enable the SQL access to the IMS database. Okay, here is a example of code again using that IMS UDB .jar file which is shipped with the IMS. The data access using the JDBC type 4 connection. Java.sql is a package in the Java standard edition library that provides access and interface to the database access using JDBC. JDBC is Java-based API that allows Java applications to interact with relational databases. And then IMS UDB.jar is the interface that interprets the SQL into the DLI requests. And then those DLI requests or the DDM commands are sent to the IMS Connect, and then IMS Connect sends it to the ODBM, which converts it to the DLI functions in order to retrieve the information. This is a sample here establishing the connection and then creating the SQL for accessing the data in the this is accessing the information metadata from the catalog. Okay, and then printing it. This is simple one, getting the information from the IMS catalog. So another way is accessing a similar kind of access using the Python. I'm using the JDB API here in the Python to establish the connection. Again, the same same driver program here. Okay, and again, this is accessing the metadata from the catalog database. Okay, we'll jump on to the next slide here. GOS batch launcher. Alternatively, you can have the programs running, batch programs running in the mainframe to create to execute the query, SQL query on the IMS database and get that information. You can have the complex queries written here like joins, and then you can create the report using the SQL queries itself from the IMS database and send those reports to the business units. JVMLT is the name of the 31-bit Java 8.0 JOS batch launcher. If you want to use the 64-bit Java 8.0 JOS batch launcher, you need to specify the JVM LDM 86 right here. And uh, obviously, you need to ensure that the Java home path and the library path settings are done corresponding to the Java SDK installed. So these path and home variables are set so that this program can run and generate the reports or the fetch the SQL data from the IMS database using SQL. Again, you'll need the DRDA port defined and then data store name here. It, it goes through the IMS Connect. Okay, next is, let's say I have the environment established to access the um, data or the SQLs. Now, how would I know that if because there are multiple blocks involved, multiple address spaces involved, how would I know where the program has been errored, and how would I um, capture the errors? This is the BMC EME Energizer for IMS Connect WODBM report. Uh, I want to highlight mm, the routing exit here. The Energizer has the capability to route the input messages to the well-equipped data store. So here you can see 89R is the input alias. There is something called aliases, need not to be real or the mm, logical alias name defined to the IMS Connect. This is pseudo alias, and then it routes it to the 85R, which is real alias. So you can create hundreds of the pseudo aliases, and the external the application in the open system need not to know the real alias name or the real data store defined. It's kind of Mhm. By you'll not let the outsiders know what's the actual data store name or the alias name, and you can route the messages to different aliases. Um, this helps in load balancing. This helps in reducing the cost. This helps in better security for the messages. Okay. Mm, uh, and you can get the more information about what was received at the time of routing, uh, what from where the message was received, client IP address. I have masked it here, but you'll see the IP address of the client machine from where the messages are being received. Then what was the client port, client ID, and then where it has been routed to. Onto the next page, I have different kind of events highlighted here. You can see the event activity description here, like message was read socket, and then DRD command exchange server attributes was received. Then you can see here once the socket read, again the DRD command access security is server security has been sent. The information related to the user ID and password has been received, and then what was the response of server exchange attributes, and then what was the response of the access security. uh, that's here this SecMac, and then DRDA reply. So you can trace the each and every at each and every interface what was received, what was sent to the next interface, and so on. And on the response also, what was received from the IMS, what was received from the ODBM into the IMS Connect and to the client. And these control blocks here, um, DRDA reply, query data sec, and the query data. We do not display the real data because it can contain the secured application information, and as part of the Energizer, we take care of not displaying the information, sensitive information here. And then you can see the trigger event completed. So from here to here, uh, till one SQL executed, uh, what all events happened, which PSB was allocated, and then which database was accessed through that PSB, ev- everything that one needs to know is captured as part of these events and reports. That helps in diagnosing the problems and understanding the message flow. This is I use this as a good training tool for the newbies in the team, um, to explain them about the flow of the messages. I um, I generally execute one transaction or one SQL query, and then get the journal, get the SLDS switched, and then run these reports to see how the messages were, um, how the messages were flowing through the system, at what point each and every message processing was done, what information was changed, and this builds the or improves my knowledge on the system. Okay, I'm gonna speak about the BMCME Energizer for IMS Connect traces. Um, we have traces, BMCME Energizer for IMS Connect traces in the BMCME command center for IMS. You can see here messages from the what message was received from the client, um, and this is the graphical user interface where it connects to the IMS Connect, or it connects to the Energizer through the BMC owned address spaces like CPC, UIM, and these address spaces facilitates the information from Energizer to BMCME command center for analytics and the visualizing the events occurring in the IMS Connect, um, real-time events. So if I speak about specific to the traces, it displays the message from the client, and then it displays the readable format of it. What was the message ID, and what protocols were used, and there is a lot more information down, what was received. Then what a message from the IMS. So what was received from client, what was received in the response from IMS, and what was sent to the client after changing the message in the user exit. And then if one needs to look into the dump records, they can click on the trace record tab and see. Then what was the result in the exit, whether it errored in the exit, or what was the response code, what was the written code. One can click in on this tab and see the information. And if one needs to know the routing information, what was the input data store requested, and what was the target data store that served the input message, that can be seen here. So this is good graphical view. Those who likes to look into the more details, um, of the each and every trace record. The techies, they can go to trace records and see. And then in the statistic tabs here, it displays the visualization of the events occurring in the IMS Connect. Okay, so um, we categorize traces mainly into transaction traces and event traces. There are many more types of traces like command traces and the journal traces, but mainly we the when you execute the transaction, it's all information in the transaction trace. Then in uh, what you can see here is inbound message, and then what was the commit mode used, and then who executed user ID, the client ID, user ID, and what message was used, data store, and then response time of that particular transaction. And this kind of information can be seen here, clubbing together the events. And then if one needs to see the details, they can go inside they can select this trace, and they can see um, a detail, what was sent to received from the client, what was sent to the IMS, how the processing was done, what was modified by the user exit before sending it to the IMS Connect, IMS Connect to the IMS OTMA, and so on. So same is true with the outbound response message from the IMS, message to the client. And uh, in the outbound message here, if I go inside the detail, if I select it to display the details, it shows the IMS Connect control blocks. What was the information that was stored in the IMS Connect control blocks, and that helps in diagnosing the problems. Here is the example of event traces. um, Again, each end to end, what happened, like begin, accept socket, prepare socket, read socket, then user message exit entered, it written from the user message exit, and then message was sent to the OTMA, and then message was received, response was received from the OTMA, and so on. Again, the response entered into the user message exit, and then close socket, and event completed. So this is for the transaction access. And if you see here the events occurring um, for the SQL access, you can see this prepare socket, then DRD command, and then message was sent to the ODBM, received from ODBM as in reply, and then write socket, event trigger complete, right up to here. The mess. So this is good information about, let's say, if something is errored here and message was not sent to the OTMA. So this helps the developer of the application to identify where exactly the error has been occurred, and target that area, or correct that area of the program, so that the transaction or the SQL access to the IMS DB gets successful. Okay, so I'm gonna speak about the uh, challenges in the different HDLC phases, and then I think I have a second last slide about collaborating DBAs with the developers, or the um, this is what I was speaking about, the R&D staff resolving their own errors, instead of getting in touch with the system administrators or DBAs, and DBAs working with the DevOps automations in order to achieve or run their stuff seamlessly. So getting back to the challenges in the HDLC phases, um, problem identification during the development and testing phases of the HDLC. Generally, what happens if the transaction has been errored, or if the developer is creating application, modifying an application, or enhancing the existing application, then when he tries to run the application and connection does not go successful, so he would need to know what is causing the uh, connection n- not going through. Uh, it could be the application itself not getting the connection done with the IMS Connect sockets or the port, and it could be IMS Connect rejecting the connection, maybe because of the password error or any error happening in the exit. And if developer doesn't get to the point why the connection is not successful, then it's gonna be time consuming, and it's gonna cost to the organization. So the another challenge is where in the IMS system uh, input message request error. So one would need to know where the error has been occurred so they can rectify it, and then locating the written codes and reason codes for the failed messages. And these kind of challenges can be resolved using BMC, AMI, Energizer for IMS Connect. Again, these are the challenges for the OpenStack developers, QAs. On the other hand, if we see the system programmers or the system admins, they have the challenge like um, a, all the input message request messages are routing to the appropriate IMS data store. Um, if one system or one LPAR is overloaded, that adds to the cost in terms of CPU. um, like is the workload balanced across the all available IMS data stores? If one IMS data store is heavily loaded, uh, then probably everybody is using that IMS system, and the other IMS system is not being utilized to the uh, optimum performance. Okay, so if this is happening, is what system programmer or the system admin needs to know. Is the test system available to the developers and QAs with no downtime during the test cycle? So when it comes time comes to deliver the developed software to the production, the testing cycles or that duration is crucial for the QA teams, and the test system needs to be available to them all the time. There can be, a team one request some configuration changes, and at the same time, team two is running their scripts, automated scripts. So if the system goes down for the ad hoc changes, then that impacts the other testing teams. So if if system programmers and system admins can do the ad hoc changes without bringing down the IMS Connect or the ODBM address spaces, that would be that is beneficial, and that's what the other um, major players in the IMS Connect and ODBM look for. And again, production system is the prime responsibility for the system programmers and the system admins when it comes for the IMS Connect or the ODBM address spaces. Um, then the major question here would be: is there a mechanism in place to trace any failures that might occur and can be fixed? If the failure occurs in the production system, one would the first thing is everyone would like the failure will not occur, and if it occurs, everyone would like that it would not repeat. So if it can be fixed for permanently, there has to be some input, or there has to be mechanism that helps in identifying the problems occurring in the IMS Connect or the ODBM address spaces. and I would say it is events and traces. Then changes to the production IMS Connect environment with no downtime is one more crucial thing to do. Um, that there could be, new addition of data stores or the changes happening to the IMS Connect environment, and system admins or the system programmers shall be able to do it with no downtime, like adding the new virtual exit, uh, or defining the new exit to the IMS Connect, and that should be uh, the, the system programmers should be able to do it without bringing down the IMS Connect address space. Okay, I'm jumping on to the next slide. Okay, evolving IMS Connect environment. Um, I'll jump to the uh, next one here. IMS Connect to the artificial intelligence models. Um, uh, there is a lot more data that comes into the IMS Connect, and real-time access to the IMS Connect data uh, through the BMC ME Energizer for IMS Connect events and traces. Um, these these events and traces contains lots of information about input messages, output messages, and this information can be used to uh, mm, to the input for the AI models. Okay, then we have something called data train from PMC AMI data stream for IMS, which extracts the real-time information from some of the events related to the security in the IMS Connect, and most of the information from the IMS logs, real-time logs, and then that information is created as a data and can be used in the AI models as a data train. Another thing we have here is offline access to JSON formatted or the CSV formatted journal reports, which can be used as data sets in the machine learning. Uh, the reports include like transaction response time or the connection history and SQL activity through the ODBM. So this information can be used as a data set um, in the machine learning to drive the mm, insights. So transaction event traces, like I showed on the previous slides, in the BMC ME Energizer for IMS Connect, journal reports can be used in descriptive, predictive, and prescriptive analytics. Um, there are different phases of the analytics I'm speaking about here. One is descriptive. It's based on the historical data, um, like um, what happened, and why that particular condition occurred in the system, is a descriptive analytics. This is where we are at the moment. We are analyzing the data um, based on events occurring in the um, IMS Connect, and then we display certain analytics, why the certain it can derive why certain events occurred. And next phase would be like predictive, predict what's gonna happen in the system. And next phase is prescriptive analytics, is you know suggesting the solutions for the um, for the problems that will be predicted. Okay, another thing I wanted to point out here is steps in the data mining is like understand the business data. Mostly BMC doesn't have the access to the business data, and every business house has their own data. So it's for those people who want to create the AI models on their data. be it be descriptive, be it be predictive, or be it be prescriptive analytics. It's like they will have to understand the business and their data, prepare the data from existing reports on the mainframe. They can use um, uh, the CSV or JSON format reports, or they can use the journal traces and events, transaction and event traces here to create the AI model. Okay, again, evolving IMS Connect. This is what I was speaking about. The statistics. We are in the descriptive phase of the analytics, and we provide the descriptive charts to the customer. What's happening in their IMS Connect environment? What kind of the message size, message rates, or the what kind of events they are receiving. There are different kinds of reports here. uh, and this is exit summary chart is one. uh, i- the users can see input message size or output message size, then number of messages errored, and so on. Lots of charts are designed in the statistics tab. Yeah. Okay. This is probably my last slide to explain. Um, Security and data recovery were among the top priorities of extra large organizations in the recent BMC survey. Then IT executives have the highest value perception within organizations towards integrating and automating database changes in CI/CD pipeline. Again, different persons have different goals. Shift left, DB developer collaboration. This is what I was speaking about. Developers, be it be mainframe developers or OpenStack developers with self-service capabilities and tools to include database changes as part of the DevOps process. They themselves can identify the problems occurring in different address spaces for their own testing. And then DBS can benefit from the DevOps automation and best practices while ensuring database changes follow data management best practices and comply with the current standards. Okay, learning more at the BMC. John O'Dowd and Dave Skipper are product owners here for the IMS. This is BMC documentation links for user guide for each of the offerings. You can scan the QR code and it will take you to the BMC docs page. Lastly, thank you, and video and slide for this presentation will be posted at the virtual group web page. If you got any follow-up questions, you can write me email. Thank you very much, guys. Any questions, or anybody wants to add anything?
I have got a question. Uh, am I audible?
Yes, Ashok.
Yes.
Yeah. Uh, so we said like, hey, to access this, we require IMS catalog, right? Now, one thing is like loading the DBDs, PSBs out there that, hey, definitions out there. And we also need to load the copybook, right? How do we load the copybook, and uh, how do we handle the occur clause and redefines while it is getting loaded to IMS catalog?
Well, IMS catalog stores the information, metadata about the databases. Um, we don't have to define the occur clause, or we don't have to load the copybooks into the catalog. It's it's metadata about the IMS databases, like what's in the field, what are the separate fields of the each segment
Yeah,
as in table, right?
yeah, and that's
Well,
where like DBD will have what is the database name, what is a segment, whether it is on level one, level
and
two, all those.
right,
PS,
right.
PSB is what has like, hey, what database it can access. Those definition, I am able to load it. Basically, we are trying to go this downhill,
Mm-hmm.
and we are stuck kind of thing wherein, hey, I loaded this. Now, when I'm going to write a code in Java, I'm going to write select field one, comma field two. That field one, field two has to be defined in IMS catalog, and that will usually come from a copybook name or somewhere. What is the
That
easy way
will
to? Yeah,
that will come. There is a um, there is standard procedure to define the catalog. When you define the catalog, or when you add the ACB to the catalog, the database ACB to the catalog,
yeah.
it creates the fields that are already defined in the DBD.
Oh, so
You
you are
don't have to
saying,
specify. Yeah.
oh no, okay. So then you are saying like in DBD you have to specify byte by byte, like hey, first 10 byte is field this, next 10 byte is,
Yes.
oh,
Yes.
okay.
Generally, in the old systems, when which didn't have the IMS, you know, I, I'm not sure if we have the alternate way available. Maybe catalog experts in the BMC would answer, and if your BMC customer, we can do the specific targeted sessions with you guys. You can
Yeah,
request that to um, Devskipper and Jonadot. Let me show that slide to you. You can write email to Jonadot or Devskipper, and we'll arrange the workshop or targeted sessions for you guys. Now, coming to your question, when you define each and every field for the segments, that automatically gets populated into the uh, catalog at the time of catalog population, and that way you don't have to insert the catalog, or you don't have to modify the catalog from the IMS Explorer.
and that's where like I I read about that. Hey, I can do that in a DVD source itself. I can give all the fields definition kind of thing. What should be the external name? But then what it means is like every time I have to go and update my DBD, and whenever I change a DBT, it means it is going to be to harden it. It's an outage that is required. When we go through a copybook route, it is just like, hey, a copybook changed. I take the book and reload it to the catalog, and the field is now available for application.
Okay, how to do that? We can do the
Yeah, I think
targeted
we will
session.
require some sessions,
Eh,
and
yeah,
I can drop that email.
yeah, definitely. Yes. Which organization you work with?
JP Morgan.
Yeah, you can write the email to John and Dave Skipper, and get the expert in that area to speak with you guys, or do the session or workshops.
Okay.
Thank you, Ashok.
And do you like anybody, any of your client in real production is using this? And in like where I'm going is like I want to understand when someone is writing a select star there, and we are coming like you are converting the DDM to DDL and DLI and then executing it. So a lot of data is getting in the network, right? How is that this going to add to the performance or to the network chatter?
Eh, IMS Connect supports the 32K response at a time. So that's expected if you are writing expecting the huge response um, um, from the IMS Connect to outside application. Uh, Obviously, the backend applications IMS Connect is a lot faster than the front end applications, and that works. But as you say, yes, it takes time to complete that SQL execution.
Okay.